Hi class, how are you today? Well, for most of you, that's great. For the rest of you, you can do better. The learning target for today is to be able to read and understand different graphs. So we're going to be learning about different types of graphs today and being able to read them and take information from them. So for the scale, a 3, you can read and understand different graphs. 2, you can read and understand only 1 or 2 graphs, but you can take all the information you need from those. 1, you can take some information from graphs, but you have trouble explaining what the graph means as a whole. And 0, you cannot take any information from graphs. Let's get started. Alright, the first type of graph we're going to talk about is dot plots. So you may have seen dot plots before. What they do is every time you have one of something, you put a dot at that thing. So let's look at this first one, times for a 100-meter sprint. So each person that ran the 100-meter sprint got a time. And so we can see one person got 10.1 seconds. 3 people got 10.2 seconds. 4 people got 10.3 seconds. 5 people got 10.4 seconds. 2 got 10.5, 3 got 10.6, 1 for 10.7, none for 10.8 or 10.9, and then 1 for 11. So that's what dot plots do. They're just number of times something showed up. You can do that again with this number of brothers and sisters. This is, each dot represents a person and how many brothers and sisters they have. So 2 people have no brothers or sisters. 3 people have 1. 5 people have 2. 3 people have 3, and 2 people have 4. These are the type of dot plots we're going to be dealing with a lot. There is another type of dot plot where it's just not dealing with numbers at all. This is more of a qualitative than a quantitative, which means it's more about taking just items instead of numbers. If you're dealing with quantitative, that's quantity, it's amount. Qualitative is more quality, what you're dealing with. So these are quantitative, this one is quantitative, where you've got a number of green cobras. So there's 1, 2, 3, 4, 5, 6, 7, 8 green cobras in the zoo. 10 rattlesnakes, 2 anacondas, 5 pythons, 4 black cobras. Next, we're going to talk about histograms. You may also know these as bar graphs. So same sort of thing, but their official name is histogram. So what histograms do is they show a varying level. Instead of making a dot for every single one, it more makes a level. So in this first one, we've got store and a final exam. So the store and the final exam, between 60 and 80, you've got about 40 people. Now with a dot plot, you would have to make 40 dots. You don't really want to do that. So that's where histograms come in handy, so they can more show range. Another thing that they do is it's a range, so it's between 60 and 80. So whether you got a 60, a 65, a 79, an 80, anywhere in between a 60 and an 80 hits this one. Anywhere from an 80 to a 100 hits this one, and so on and so forth. So they work really well because you can get ranges instead of middle ones, instead of just every single range. So instead of having 5 dots for 62, 3 dots for 73, you can just lump them all into one. In this one over here, same thing. You've got length of the Greek tragedies in words. And then you've got frequency over here. Whenever you see frequency, that just means how many. So in this case, we're talking about how many Greek tragedies. So 2 Greek tragedies have their words between 4,000 and 5,000. 6 have between 5,000 and 6,000. And you can read it from there. Sometimes the drafts just put the range down there. So this one is M&M as a favorite candy, age groups and years. So you've got a 0.5 range, a 6 to 10 range, an 11 to 15 range, and so on. So sometimes you can have the ranges out like this, or you can just... The last graph we're going to talk about today is box plots. So box plots may have been the only one you haven't heard of before. It's probably the most likely. What box plots do, instead of showing amounts, they show percentages. So in all these box plots, you've got a box, and you've also got these things called whiskers. Sometimes these are called box and whisker plots, because we've got our boxes and our whiskers at the end. So what box and whisker plots do is they take the amount of anything they see and they graph it based on percentages. So they would take, like, say, a dot plot and then turn it into a box plot. So you may have heard the term median before. What the median is if you take all the numbers you have and put them in order, the middle number, the exact middle number, will be the median. Then from there with the box plots, they'd then, for the third quartile, go from the median to the maximum, the biggest number and the middle number, and then find another middle number. And then same thing from the min to the median, find another median. So the first quartile and the third quartile are essentially the medians of the medians. So what these boxes and whiskers represent, each section is worth 25% of the data. So we've got 25% of the data there, 25% of the data there, 25% of the data there, 25% of the data there. We'll go more into box plots later when we talk about creating them. But for right now, I do want you to understand how to read them. It's 25% of the data falls between about 35 to 44. That means the smaller these boxes are, the more data that's inside them. So if you jump down to this one right here, this box is really small. There's a lot of data between about 62 and 69. A lot of data right here. So if you had a dot plot, a lot of your dots would be in this area. And there'd be a lot less dots in this huge area. So there'd be more dots in this area than in this one. And there'd be more dots in this area than in this one. So the bigger it is, the less dots there would be. Alright, so now we're going to talk about symmetry versus skewness. So, you've probably heard the word symmetry before. It's when two things, or something, if something is symmetrical, it is the same on either side. And with graphs, you won't always have something that's perfectly symmetrical, but you'll have things that are pretty much symmetrical. They're close enough to being symmetrical. So let's look at a few of these graphs. So the opposite of symmetry is skewness. And with skewness, the graph is sort of pulled to one side or the other. And we'll talk more about that in a second. But with skewness, you can be skewed to one way or another, but it sort of pulls it from one side to another to get rid of the symmetry. So let's look at some ones that are symmetrical, or pretty close. This first one right here, we've got a box plot, and the box on the right of the median and the box on the left of the median pretty close to the same size. You can definitely see that the right one is a little bit smaller, but close enough. And then the whiskers on both sides look pretty much the same length. So we would call this one symmetrical. Now with this one, however, this box plot over here, the whisker to the left and the box to the left are both much, much smaller than the box to the right and the whisker to the right. So that means there's a lot more data on the left than there is on the right. So when you have these random data points that are few and far between on one side, that is the way it's being skewed. So in a box plot, when it's being pulled more to one side, we say that it's skewed to that side. So this one is skewed to the right. Now, let's look at the histograms. With this histogram here, obviously it's not fully symmetrical, but it looks pretty close. The yellow and the orange bar differ a little bit. The red and the black are pretty much, the red and the brown are pretty much the same height. And then there's a little green not doing much there. So while they're definitely not perfectly symmetrical, they are close enough to be called such. I would definitely not call it skewed. Now, the bottom histogram, on the other hand, this one, you've got a lot of data in this area, even in this whole area here, but then there's this data pulling it down that's a bit farther away. So it's much lower here. If you're looking like a curve, there's much more data over here than there is over here. So it's being pulled more over this way. So we call this skewed in that direction. So that would be skewed to the left. Okay? Next, let's look at this dot plot here. So this one's going up nicely, and then all of a sudden on the right, it's kind of a bit more all over the place, with some data points that are far away pulling the mean to one side. And we'll talk more about mean and median in upcoming lessons, but when you've got one or a few data points that are pulling to one side, you're pulling the mean away, and you're making the mean different on what it more typically would look like. So in this case, again, we would be skewed. Skewed to the right. And I apologize for the writing, my board's not working very well right now. And then finally, this dot plot right here. You've got some in the middle, and then 3 on either side of that, and then 2 on the ends. Those are perfectly symmetrical. Alright, that's all I'm going to do for the lesson today. No sponge today, but I will be doing sponges in future videos. So, take notes on this entire lesson. Please make sure to take notes on everything, even though there wasn't a sponge. Still need to see all the notes. Take a picture of it all, submit it to eBackpack.